digital algorithm because we want the shortest path. We want the shortest path within a graph. For example, in the computer networks, we have multiple paths from source A to destination. Okay, so in between, definitely we use some shortest path. Okay, or if this shortest path we are using in our daily life, that we want to go to Quantan, to Cal. So we always find the shortest path, like any road jam in between. So we go for alternate path. This is the application of register algorithm. So in computer system, in network, we have different routes. We have a lot of routes. So based on this algorithm, we can find the shortest route. Okay, do you hear me clearly?
Yes, sir, can hear.
Yes, sir.
Okay. So now see, just see the register algorithm, level 1. We have 2 levels. So in this video, we will learn to find the shortest path from vertex A to vertex D using register algorithm. Before we already seen Prim's algorithm and Pushkal algorithm. So today we'll see only register algorithm part 1 and part 2. Again, before we start, I will request you to some paper and pen and solve this problem. With me, this will help you to understanding the algorithm better. So this is our graph. Let me share the link with other students also. I just shared in one group. Okay, so I already shared the link in all the groups just now. Okay, 1, 2, 3, 4. All you received. Okay, good. So here's our graph. If you see the graph, we have initial vertex. See, the yellow one is the source or initial vertex, and the green one is the final vertex. Mean our packet, our data will move from A to D. And other thing, edges, you know the edge, you know the weights. Okay, so it means that our in digital algorithm we have two things: initial vertex and final vertex, and we can say source and destination. Okay, remove our loops. Same thing. Remove all parallel edges. So we'll keep 10. Okay. Now we ready to find the shortest path from vertex A to vertex D. A to D. So draw this graph on a separate paper. So we will be using in our calculation. So number 3, create shortest path table. We have to create one table. As our vertex has 4 vertices, A, B, C, D. So our table will have 4 columns. After removing the loop, after removing the parallel link, this is our step 3 to create a shortest path table. We already started, we have 4 vertices, we will use 4 columns. So column name is same as the name of vertex A, B, C, D. Now in the row first, now write 0 in column A and infinity in other column, because we are, why we write 0 in first column, because we are at initial level. We are, see, you have to write 0 in column A and other column infinity. Always you write this. We have written 0 because our vertex is source. We are in the initial vertex. Always you have to write 0 when you write the initial. So we have written 0 in the column A because vertex A is our source. Okay, and rest you write the infinity. Okay, so value is in the columns denote the weights of the shortest path. So we have to write here the weights. So 0 in column A denotes we are at vertex A, and infinity in all other column denotes unexplored vertex, because we are just in the initial level, in a source. That's why we retain 0 and rest infinity. Now the first row is completed filled. Our next job to find the smallest unmarked value in the row 1. So looking at the table, we can say that 0 is the smallest unmarked value in a first row. So we mark it in the square box, because others are infinity. So small only 0. Yes. Now draw another row and copy all the marked values in the new row. In this case, we just copy the 0. Okay, so next row, what we have to do, we will draw that row and just mark the values in new row. So in new row, we have only one marked value, which is 0. So 0 copied in the next row. As column A was marked in the previous step, so we look for edge that are directly connected with the vertex A. Okay. So how many vertex? 5 and 10. Or B and C. So find the edge that directly connect A and B. So only for A, B? Yes. In this case, we have an edge of weight 5 that directly connect A and B. For AB, yes, only 5. So we write the weight 5. Okay, we have to write some formula here. So now before we proceed further, I want to tell you something. So for example, if we consider two vertex x means source, and y means destination, and an edge that directly connects them. So see the formula. Then we have a formula. See, minimum, minimum is a function. Minimum function, bracket destination value, comma, mark value, plus edge. This is formula. How? We just go for one example, simple. Destination value, the value in the destination vertex y column. Mark value, the value in a source vertex x column. And the edge weight, the weight of the edge that connects the source x and the destination y. For example, the weight is the value basically that connects the source and x and y. We see the example for the formula. Okay, for example, we have to solve this. So we will get the minimum value that we'll put in the destination vertex y column. How? Suppose, for example, if destination is equal to 10, mark value is 5, age is 4, so putting value we get minimum 10 comma 5 plus 4. Minimum is a function. Minimum function actually. It will give us the minimum value. So we have 10 comma 5 plus 4. 5 is a mark value and 4 is the edge. So the value will be minimum 10 comma 9. So 9 will be the answer. So minimum 10 comma 9. So 9 is smaller than 10. So 9 is smaller. So it will give us smaller value. Let me show again. Okay. So we use minimum function. The formula is minimum destination value comma mark value plus edge value. Okay, so yes, 10 comma 9 and 9 is a smaller than 10. Okay. So now looking at the graph, so as we considering an edge between A and B, so source vertex is A and vertex B is our destination. So in this case, we have the edge of weight 5 that directly connects A to B. So formula is very simple. This is our destination value and this is our mark value. See, B is destination, A is mark, and edge is 5. So in this case, we will write minimum infinity is our destination value, comma 0 is our mark value, source value, plus weight is 5. So A to B weight is 5. In this case, we will get 5. Solving minimum infinity comma 0 plus 5 we get 5 because infinity is a larger value, 0 plus 5. So larger value plus 5 comma 5, the minimum will be 5. So we'll put the value 5 in the column B. Like this. Okay. Understand this method? Yes, please. Understand this? How we get the value of B?
Yes, sir. Understand.
Yes, yes. Understand?
Yes, sir.
Okay, very simple, very easy. I already shared the link. You can repeat again and again. So now find the edge that directly connects vertex A to C. Now we see A to C. First A to B and then A to C. If we talk about the very first, we just write about the A0 and BCD or infinity. Then we find A to B and then A to C. So for A to C, the source vertex is A, destination vertex is C. In this case, we have a edge is 10. So very simple. We put this in the formula. C is infinity.
The top three reasons why people lose money is they don't have a rules, right? They just buy, but they don't know how to get out. And you
Okay. So we'll get minimum infinity comma 0 plus 10. So we'll write 10. Now we find A to D. So A to D, we don't have direct link. Okay, so now find the edge that directly connects A to D. So looking at our graph, so we find no such edge that directly connects A to D. So we'll simply copy the previous value in the column D. Okay, so we have to copy the previous value in column D, which is infinity. Now the second row is complete, filled. Our first job is find the smallest unmarked value in row 2. So smallest unmarked value will be 5. Looking at the table, we can say that 5 is the smallest unmarked value because infinity contain all the values. 10 is more and 5 is only value which is less than 10. So for the 5, we will mark with the square box. Okay. Now draw another row and copy all the marked value in the new row. In this case, 0 and 5. You have to always copy the marked value in a new row. So here, currently we have two marked values, 0 and 5. So we already copy. As column B was marked in the previous step, so we'll now look for the edge that directly connect with vertex B. Now we'll see B. And we don't have to consider vertex A is already marked. Okay. Now we go for vertex B. So vertex B, we have BC, we have BD. So no need to go for A. A already marked. Because A to B and B to A, simple thing, same thing. So find the edge that directly connect B to C. So in this case, we have an edge of weight 4 that directly connect B to C. So we are considering an edge between B and C. So source vertex is B, and destination is C. So our C is 10, source is mark value is 5, so edge value is 4. So minimum value 10, destination comma 5 plus 4. 5 basically is the source value and 4 is the edge. B to C edge is 4. So we'll get 9. We just write 9 there. And then B to D. We find B to D. B to D, the weight is 11. D is infinity. And B is 5. Edge is 11. So here we get 16. Very simple. Now the third row is completely filled. Our next job is to find the smallest unmarked value in row 3. So in row 3, the smallest unmarked value is 9. Unmarked value. Now draw another row and copy all the marked value in the new row. In this case, 0, 5, and 9 we mark in our new row. So as column C was marked in the previous step, so we will look for the edge that directly connect with vertex C. So note we don't have to consider vertex AB as they already marked. So now find the edge that directly connects C and D. So for C and D we have only one. In this case we have the edge of weight 5 that directly connects C and D. So C is our source, D is our destination. So we know the value of C is 9, destination is 16, edge is 5. So we have 14. Value is 14. Yes. So see our table is. Now the fourth row is completely filled. Our next job is to find the smallest unmarked value in the 4 row, which is 14 only. We have only one value. So which is 14. So we mark the with the square bracket. So our final vertex D is marked. So we stop here. So our table is completely filled. Column D has marked the value 14. This means our shortest path has the weight 14. Okay, then time to find the shortest path using backtracking. Now we will do backtracking to find the shortest path. Okay, we will start from D now. See, first we start from A and fill the table. Now we will mark the shortest path. We start from the D. So take the mark D as its destination vertex. We will take, highlight. So backtracking is very simple. We will move upward row by row. Okay, we'll move upward row by row. And we stop only when we find a change in a value. When we find a change in value. If same value, no. And we stop until we find a change in value. So we take the D. D is our destination. So start from the final mark value 10. Follow the steps carefully now. this is, we are here D. So now we move one row up. We move one row up. Okay, we move one row up. Has the value changed? Yes, because value is 14 from 16. Yes, it is 16. So take the vertex that was marked in that row. Okay, we will mark the vertex. First, we already marked D because D is our destination. Then we go up. We go up. Next row. So next row change 16. So this is vertex C. Okay, so move the pointer to the value 9 in column C. So now we'll move because up is infinity. We don't go up. So we'll go left side towards the 9. Okay, 9. So now move one row up. Here we move one row up always. So any change? Yes, because in C9 now it's 10. We mark that vertex also. And then we move left because we can't move up. So left, we have 5. One move up, so it's infinity. Has a value change? Yes, it's infinity change. So take the vertex was marked in that row. So since the initial vertex is ticked, so we can stop here. Therefore, the required shortest path is A, B, C, and D. A, B, C, and D. So this is the highlight that path. So in this case, there are 2 or more columns with the same smallest unparked value. Then you can choose any one of them. Can. This only denote that there will be more than one shortest path in the graph. So we can go for any smallest value. So this is our shortest path. Yes, understand? Or you want to repeat again?
Understand, sir.
Understand, sir.
So I already shared the link. You can see this video because this is a very simple video, easy video. So you will get at least one question from Prim's algorithm or Kushkal algorithm or digital algorithm. At least one question. No, level 2. Now I'm sharing the level 2 also. Level 2 normally no need, but okay, let me share the link for level 2. So I already shared. So this is level 2. Same thing. Just now you have more vertex, A to F. So this is our initial vertex A, and the final is F. And you know everything, the initial vertex. First you have to remove the loops. We have removed loops. Now parallel edge, we'll keep 10. So same thing you have to repeat here, but you have more vertex here. 6 vertex. So we have 6 columns. Okay, same thing. For first column, just write 0 in source and other infinity. Very simple. And for B, we will copy this mark value in B. So we'll see now A to B. The weight is 10. Again, let's recap For level 1, the same formula. Okay, x and y, x is source, y is destination. Formula is minimum function of destination value, comma, mark value plus edge value. Mark value plus edge weight. Same thing. So 9 will be answer. So same formula we write here. Now we'll find A to C. Weight is 5. The minimum value is 5. Very simple. Understand, because A is 0. Okay, very simple. A is 0, weight is 10. So 10. Here A is 0, weight is 5. So we don't have A to D. We don't have A to E. We don't have A to F direct. Okay, we copy the mark values. So we write here. See again. As column C was marked in the previous step, so we will look for the edges that are directly connected with the C. If you see C, for example, C to B, B to C already done. Okay, you have, for example, here C, we have E, we have B, we have A. So find the edge that you connect from C to B. Now C to B. So in this case, we have the edge 8 here. Okay, and the destination is our B. Okay, and C is 5. So B is 10, C is 5, weight is 8. We got 10. Now C to E. Weight is 12. E is infinity, destination is infinity. So C is 5. So we write 17. So no directly connected with F, so we write infinity.
Moomoo, #1 trading app in Malaysia. Join Moomoo and Bursa Malaysia Trading Challenge.
Now again, we have to complete till F. We copy all mark values. Now B and D. Okay.   Okay.
the
We'll copy because no direct edge for F. Yes, no issue. This is for E. Same thing actually. We have done in previous level 1. E to F. Check the graph. E to F, yes, it's a 6. So we get 22. T to F, we don't have. T to F, check the graph. So yes, we have 4. And the value will be 22. D22, okay. So we stop here. We already finalized all 6 vertex. Now I am here. F. We will do backtracking. We start from F. We mark F. So now find the shortest path. We have to backtrack from the final vertex. So backtracking is very simple. We will move upward till we find a change in value. Okay, we will move upward till we find a change value. So we are in F. So we go to. So let's start for the final mark value 22. Follow the step. So move upward as value change. So it is still 22. No change. Again move up. Change yes is infinity now. Then move to left. Then up, yes, value change. Value change, we mark. Okay. As value change, no, still 10. So move up. Yes, it's infinity. So we stop here. So A to B, B to E, and F. A, B, E, F. A, B, E, F. This is our shortest path. So this is our shortest path. This is 22 unit. 10 plus 6 plus 6, 22. So for A to F, we have like this path also A, C, E, F. If you count A, C, E, F, so see 17, 23, 26, A, B, D, F. A, C, D, E, F. Oh, too many values. So This is the shortest path. So you can repeat this video again. So the important is backtracking. In backtracking is a bit tricky. Yes, you have to follow the rule just. So I already shared both the videos. We have only one or maximum two or one, maybe one algorithm is left. Right, Koshkar, just algorithm. Okay. Okay, Johnson and Floyd's algorithm. So repeat again. Register level 2, level 1 both. One time at least, 2-3 times. Yes, you already repeat.
Yes, sir.
Okay, so next we have only one algorithm, which is Floyd's algorithm. We will see next. So this will be our last algorithm. So Prem's Kruskal disaster, and one more is Floyd's algorithm. Maybe one more. So 5 or 6 algorithms are enough. Okay, inshallah. We have 1 or 2 algorithms based on the scheme of study. We will see in next week. I hope next week there will be no holiday. Okay. Any question?
So far, no, sir.
Okay, if no question, you may leave. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.